Hello troopers and welcome to the monthly Status Entropos dev blog. In this video we want to talk about the part of game development that always stays behind the scenes. Programming. How the code is made, how the engine works, and what technical team is working on right now. Enjoy! When you decide to make your own game, along with questions like what will it be about, how will it look like, and who will enjoy it, there's always another key question. What engine will it run on? Here you face a choice. Build your own engine from scratch or pick something ready-made. A custom engine has one undeniable advantage. It is built exactly for you. You'll know it inside out since you made it yourself. But it also takes a colossal amount of time, which hits the budget hard and delays both release and updates. Plus, only you will know how the engine works. New developers will need a long and costly onboarding, and when problems come up, there might be no one to help you. That's why indie developers and increasingly even AAA studios often choose ready-made engines like CryEngine, Unity, Unreal Engine, Godot, and others. Most often, though, it comes down to Unity or Unreal, two major freemium engines with a strong base of ready tools. You can take them, add your own mechanics and systems on top, and get going. They are easier to learn, and there are plenty of specialists available from day one. So why did we choose Unreal Engine and not Unity? It is generally believed that Unity is convenient for a quick entry, simple prototyping, and indie development. It uses a simpler C# language and offers a huge number of libraries, assets, and plugins. But that becomes a problem long term. Many critical systems in Unity are written by third parties. Networking, for example, isn't included by default. Adding new mechanics often means stitching together code from different people. This creates risks. If a plugin stops being updated or has bugs, you must fix yourself, each time diving into someone else's code. Teams making AA and bigger projects eventually run into architectural limits, dependence on third-party libraries, and optimization headaches. Unreal Engine, on the other hand, is much more suited to rapid prototyping and wins in terms of flexibility and clarity for long-term projects. The engine has a built-in prototyping tool, Blueprints, which is simple visual programming that greatly speeds up early R&D, research and testing of ideas. At the same time, key systems are transferred to much more powerful C++ language, which gives complete control over performance and code cleanliness in the long run. And for medium and large projects, Unreal becomes a more stable solution than Unity. And most importantly, Unreal Engine was built for multiplayer games from the very start. For us, it's critical. But as you may know, Unreal Engine is not perfect. The first problem with a ready-made engine is that its creators don't know what game you're making. It could be a shooter, a racing game, or a strategy, so they include a wide toolkit for everything. But why would you need flight or swimming systems if you're making, say, a visual novel? All of this makes the engine heavy, and if you're making a more complex project, these ready-made solutions aren't enough anyway. You'll still need to write your own systems from scratch, ideally cutting out all the unnecessary parts of the engine. That's why we work with the engine's source code rather than its standard builds. Still, rewriting parts of Unreal to fit your needs is nothing compared to building an entire engine. With Unreal Engine, it's still Epic Games' job to maintain the engine, research and add new technologies and provide services. Yeah, Epic builds truly epic technologies and lowers the entry barrier for using them, which is both great and dangerous. Game developers often perceive these technologies as a panacea, a magic checkmark that just makes it beautiful. But the price for that is optimization, and then players blame the engine. And Epic themselves hype up these new technologies. Even if you're just a casual gamer, you've probably heard of the buzz surrounding Lumen and Nanite. In reality, only few projects really need all these innovations, but they are making the engine heavier and heavier, although not to the extent that is commonly believed. We chose Unreal Engine 5 not because of Lumen or Nanite. On the contrary, they tend to interfere, but because it's faster to work with. Epic expanded prototyping options, streamlined input systems and debugging tools, and overall made the engine more convenient. Sure, Status Entropos could have been built in Unreal Engine 4, especially since we write a lot from scratch, but UE5 just makes the workflow smoother. Many Unreal features really do let you just tick a box and get decent results, but that comes with its limits. For a simple game, the standard functions are more than enough, but for a more complex one, they can box you in. By sticking to simple solutions, you can prototype and test pretty quickly, but sooner or later, they trip you up. For example, Unreal has built-in movement modes: walking, running, jumping, swimming, falling, flying, and so on. Not all of these are needed for us, but at the same time it lacks what we do need: leans, non-standard stance changes when standing, crouching, or especially prone. The biggest issue is prediction. Unreal's default system is basic. For a high lethality shooter like ours, latency and dying behind walls is unforgivable. Players of the early builds of Status Entropos know how bad that felt. And yeah, we're sorry about that. What is this prediction system that we are missing? Most likely you have encountered deaths behind walls in various games. This is a natural result if all calculations are sent to the server. For example, imagine a situation where you spot an enemy and you want to run behind a wall. But you've only sent a request to the server and now you have to wait for the server to process it, allow you to move, and finally move on your computer. Movement feels unpleasant and sluggish, and that's how it worked in the May version of Status Entropos. It can be done slightly differently. In the example of taking cover, as soon as you press the button, the game should immediately show that you have started to move. This simple solution will eliminate the feeling of sluggish controls while your position still has severe priority for synchronization, reducing lag for other players, and combating cheats. However, due to high ping, your position on screen and your actual position on the server will be different. You will often die seemingly after already taking cover. To avoid this, there is a prediction system. We will immediately show the player an illusion that they started running immediately after pressing the button, and while at the same time the request is only being sent to the server. But now the movement you see on screen and the position on the server begin to synchronize and converge to the same coordinates, taking into account the delay. This is not the simplest system because in addition to the player's position, there is also shooting, changes in body stance, a player can change the direction of movement, and so on. And that takes time. It's the classic trade-off between time, quality, and price. By creating quick temporary solutions, you risk getting caught up in a cycle of half measures and crutches, which will have to be redone properly anyway. As a result, development will take even longer than if you had done it right from the start. If in the prototyping phase we adhere to the approach of doing what the budget and time allow, that is, cheaply and quickly, then now with your support we are mainly adhering to the approach of doing it right, which is why we are rewriting the game from scratch. However, the prediction system is precisely what will break this pattern. Unfortunately, developing a good prediction system, linking existing mechanics to it and creating entry points for future mechanics will take months, which we simply do not have. Therefore, the upcoming tests of the new multiplayer version will not have the best hit registration. But the coding team will start working on prediction systems in the winter. Overall, we want to fill the game with new systems, mechanics, and content, even if it's in small but high-quality steps. And the thing you've all been asking for regarding UE5, it's optimization. As we've already figured out, Unreal's accessibility, coupled with its simple technologies, makes game development open to almost anyone. But if the developer doesn't have the budget, time, or experience to rewrite the basic components to suit their needs, cut off the parts of the engine that are unnecessary for the project, and especially if there is stacking of third-party assets and plugins, all these seemingly insignificant details add up, and the game inevitably becomes too heavy. In addition, Unreal Engine 5 itself is still under development and many of its features are only in experimental mode. There are constant problems with server builds or some radical unpredictable changes from version to version. Custom solutions allow for more stable performance, good optimizations, and getting rid of overloaded basic functionality. In our work, we obviously strive for maximum game performance. We work out the architecture of the project as a modular component solution, connect and think through the interaction between modules, and strive for maximum code speed. The same applies to graphics. 3D artists widely use normal map systems, calculate the correct texture resolutions based on the surface area of the model so that the texture takes up less space and video memory, and strive to reduce the number of polygons, as ironic as it may sound for a low-poly game at the first glance. It is a misconception that low-poly games do not need to be optimized. Moreover, when creating highly detailed models and textures, we use the same technologies and follow the same project optimization standards that are accepted in the gaming industry for photorealistic graphics. All of this is relevant, for example, to our updated characters, such as the new model for Karen, a sniper from the American PMC Echelon. With improved visuals, there are even fewer polygons. However, it is important to note that we regularly receive questions about the game's availability on mobile platforms and ultra-low-end PCs. But we need to say something. All our optimization efforts do not mean that we are striving to make the game work on a Raspberry Pi connected to a lemon. We are targeting normal average PCs, and we are directing the resources freed up by optimization towards new opportunities for players. Mechanics, content customization, destructibility, sound and lighting quality, animation systems, and so on. To quote our technical director, "We don't want to give players crap, we want to release as good and as exciting game as we can." In the first half of the summer, we finished writing our own services. These are not only game servers that you will soon be playing on, but also a larger layer of systems ranging from authorization and accounts to the ability to link them to the game website, as well as a customer verification systems, anti-cheat modules, and the ability to work with third-party services such as Steam, Epic Game Store, Epic Online Services, and others. We have made drafts for progression system, purchases, matchmaking, and so on, all with modern custom protection methods. This is an essential foundation of the game, without which the rest of the game mechanics cannot be implemented. Right now, the programming team is finishing up work on a new weapon kinematics and recoil system that will replace the procedural animations and the random recoil system. The new system will be based on behavior of real weapons, but we'll talk more about that in the next issue, where we'll show you lots of interesting stuff from under the hood. In October, we'll finish some smaller features and prepare for playtests in November. We hope this video wasn't too heavy on tech and you found it interesting. This month's budget is on your screen, and as always, thank you for supporting the development, thank you for supporting us. You guys are truly making this happen. That's all for now. Subscribe to the channel, wishlist Status Entropos on Steam, and join our community on Discord and other socials. And as always, at ease, troopers!